Questions on any of the homework assignments? All right. Questions on the homework? Questions on any of the homework assignments? All right. If we feel... All right, guys, let's focus in. Complex conjugates. Complex conjugate theorem. We do have all this here, but the main thing is A plus BI's complex conjugate is A minus BI. Complex conjugate. A plus BI's complex conjugate is A minus BI. A minus BI's complex conjugate is A plus BI. That's it. Now, the complex conjugate theorem states if A plus BI is a solution, A minus BI is a solution too. If we have one, we have to have the other. They always come in pairs. Okay? Are we ready for this?
Okay.
What is 7 minus i's complex conjugate? I actually heard it. It would be what? 7? It would be negative 5 minus 5i's complex conjugate. And that is it. Yeah, that's it. Questions on the first two? Okay. Now, before we move on to the next two, I want to look at number 1. It doesn't ask for this, but what I'm going to do is take the complex conjugates and find their product. I'm going to take the two complex conjugates and we're going to multiply them together. So if we multiply these together, first thing we're going to do is 7 times 7, which is 49. Excuse me. 7 times I is going to be plus 7i. Now we're going to do negative I times 7, which is negative 7i. And lastly, negative I times I is negative I squared. Let's combine like terms. What is 7i minus 7i? No I. So that would be 0. So we still have our negative, well, I squared is negative 1. Negative and negative makes a. And 49 plus 1 is 50. So this is the interesting thing about complex conjugates, because if we multiply the two together, we get an expression without I. That's why these are nice, or why they work well. Because when we multiply them together, it removes the i's from the expression. Yes. Here you go. Mm-hmm. All right. Questions on this here? All right. Let's look at the next two. Negative 2 plus 4i's complex conjugate would be? Minus 4i. 3 minus 6i would be? And again, if we multiply these together, we would get an expression without I. Which one do we want to multiply together? We're going to do one more. Which one? 2 plus... Wait. Oh, 3 plus 6. So we'll do the 3 minus 6i and the 3 plus 6i. So if we multiply this out, we start off with 3 times 3, which is 9. 3 times 6i is going to be plus 18i. Negative 6i times 3 would be negative 18i. And negative 6i times 6i is going to be negative 36i squared. So we still have the 9. Our 18i minus 18i is 0. Minus 36, well, I squared is negative 1. Negative 36 times negative 1, it will make it I think my brain got ahead of itself because negative 36 would make it positive 36. And 9 plus 36 is 45. Yeah. Apparently I spaced out and wrote 45 a step early. I didn't even realize I did that. All right. Now, this here, the 3 minus 6i times 3 plus 6i, that's just the multiplication we did yesterday, yes? Which means we can technically do that in the graphing calculator, yes? So we don't have to do it by hand. The graphing calculator can do that for us. Okay. Let's look at the next two. 10 minus 2i would be plus 2i. Negative 4 minus 8i would be negative 4 plus 8i. Questions on 5 and 6? We feel good with 5 and 6? 7 and 8. 7 would be negative 4 plus 3i. 8. We like these here.
Yep.
All right. Let's do one more. What would be the complex conjugate of 9i? Mm-hmm. Complex conjugate of 14.
Oh, wait. Question mark. I didn't think it was going to be anything because I didn't have I in it, but I was trying to keep.
Well, I can give it an I term because we can say plus 0i, yes? Which means its complex conjugate would be. So the complex conjugate of 14 is 14. Because we're only changing the sign in front of I. Yeah. I just throw those in just so that we can see it does still work with both. If we just have a real number, it really doesn't change it because it's still the real number. But this also means that I can write any number as a complex number. Because we can always add 0i to any number and it's now a complex number. But questions on this so far? All right, let's divide. We want to write each quotient in standard form. So for us to have this in standard form, one of the things is we do not need and we cannot have I in the bottom of the fraction. Now, I need to go back and fix these and make these slides a little bit bigger. Y'all don't have to rewrite this. Y'all can just do times and next to it. I'm going to rewrite it so that we can see it a little better. So on your note sheet, you don't have to rewrite this. I'm just rewriting it so that it's a little bit bigger. You can just write the multiplication right out next to it. Now, the issue is coming with our 1 minus 2i. We can't have that 2i in the bottom of the fraction. So I need to multiply this by something to get the I to go away. And specifically, we're going to multiply it by its conjugate. Specifically, the conjugate, complex conjugate of the denominator of the bottom of the fraction. Because as we saw already, when I multiply 1 minus 2i with 1 plus 2i, we get a single number. The I terms will cancel out. And part of the reason this works is we're actually multiplying this by a fancy version of 1. Because 1 plus 2i divided by 1 plus 2i, anything divided by itself is 1. So we're not actually changing anything. So the first thing we're going to do is multiply. Now the parentheses are there, they're not technically written. But all we're doing is distributing. So the first thing we can do is 4 times 1, which is 4. And then we can do 4 times 2i is plus 8i. Then we'll move on to our 3i. 3i times 1, which is plus 3i. And lastly, 3i times 2i, which is going to be plus 6i squared. Questions on the top? We're ready for the bottom. So we can do the same thing. We're going to do 1 times 1, which is 1. 1 times 2i, which is plus 2i. Negative 2i times 1 is negative 2i. And negative 2i times 2i is going to be negative 4i squared. Questions on this so far? Now our 8i plus 3i is going to be plus 11i. Now we could have just switched the signs with our 6 because our I squared is negative 1, which is just really going to turn it from positive 6 to negative 6. In the denominator, 2i minus 2i is 0. So we're still left with our 1 minus 4 times negative 1 because our I squared is negative 1. So on top, we do have 4 minus 6 because our 6 times negative 1 would give us negative 6 plus 11i. On the denominator bottom, negative 4 times negative 1 would give us plus 4. Really telling us that we have negative 2 plus 11i over 5. Questions on this here so far? Questions on anything we've done so far? Now technically this is not in standard form because we needed an a plus bi. I'll take either one, because really we just have to split it back up into its 2 parts, A and B. As bad as you thought these were going to be? Not too bad. Yeah, you can go on and try it. Questions on this here? Alpha y equals enter. Any questions on the first one? We're going to look at one more, multiplying it out, and then we'll look at it with the calculator. So the other one we have on the front is 1 minus 4i over 2 plus 3i. Again, I'm going to rewrite it so it's a little bit easier to see. You do not have to rewrite it, because I think relative size-wise, it's a little bit larger on your paper than it is on that screen. Okay. So again, we need to get I out of the bottom of the fraction, and to do that, we're going to multiply it by its complex conjugate, R2 minus 3i. Does it work out? we'll come across that here in a second. Now, first thing we have to do on the top is we have to multiply this out. So 1 times 2 is 2. 1 times negative 3i is negative 3i. Then we can do the same thing with negative 4i. Negative 4i times 2 is negative 8i. Negative 4i times negative 3i is going to be plus 12i squared. Then we're going to do the same thing with the bottom of the fraction. 2 times 2 is 4. 2 times negative 3 is negative 6i. 3i times 2 is plus 6i, and 3i times negative 3i is negative 9i squared. And on top, we still have our 2. I'm going to move the 12 over and just say plus 12 times negative 1. Our negative 3i minus 8i is negative 11i. On bottom, we still have the 4. Our negative 9i squared is going to become negative 9 times negative 1, because really that negative 9i squared and that 4 are going to become like terms. They're just not there yet. Negative 6i plus 6i is 0, bless you. All right. Negative 1 times 12 is going to be negative 12. On bottom, negative 9 times negative 1 is plus 9, telling us that we have negative 10 minus 11 I over 13. Or in standard form, we just break up the two fractions. Now, if there is a like term, or if they can reduce, once we break them apart, we would want to break them apart if there's, not break them apart, simplify them. Because if we break it apart and there's something in common on top and bottom, reduce it down. Don't leave it as 4/8. Rewrite it as 1/2. Oh, here it is. Questions on this here? All right. Let's look at the graphing calculator. Because up to this point, the graphing calculator has been able to do all these so far, yes? Alpha y equals enter. Let's do the first one. 4 plus 3 I over 1 minus 2i. Which part? Okay. Alpha y equals enter will give you the fraction. Green button, go up from there for y equals. Enter. If you're looking for I, it is second decimal. Once you get it all typed in, hit enter. Okay. We all get it typed in? Yes. And I think it's giving you all an error code across the board, yes? So when I hit enter, it gives us, there's one big difference here. Y'all's, the graphing calculators y'all are using are TI-84 plus, yes? The one on the board is not a TI-84 plus, it's a TI-84 plus CE. It's a color edition. Because again, like the 83s, I told you all they can't do the alpha y equals enter, they don't do the nice fraction. These don't simplify this with fractions. They still do it, we just have to do it a little different, all right? Because a fraction is just another way to do, or another way to write division. Parentheses, 4 plus 3i, close parentheses, divided by 1 minus 2i. We have to put parentheses around the top, divided by parentheses around the bottom. We have to write it in as a division. So typing this in. Yours, we'll do it just as because it is a CE. Yeah. And again, from one addition to the other, there's very little that changes, especially from the 83 to 84. 89s and spires do have a little bit more. And I think y'all got this here, yes? Okay, we have one last set of steps. You ready? Math, enter, enter. Math, right under alpha, that first option that we're selecting is pretty much saying take the previous answer and turn it into fractional form. And that's what we got, yes? That's it. So the next one, so second one we did 1 minus 4i divided by 2 plus 3i. We get this here, but if we hit math, enter, enter, turns it into negative 10 thirteenths minus 11 thirteenths. All right. But I would say, especially if you type it into the calculator, make sure you put parentheses around the top, both expressions, before you divide. Because if you do not, especially with the last one, it will divide the negative 4i in 2 and treat everything else as addition and subtraction. Questions on this here? You're welcome. And that's really it. The rest of the back of that sheet is just more examples of doing those there. You're welcome. Yeah. Yes. On the front side, that first page, the first 5 problems on this assignment, you should have 2 answers. It says 1 through 5, find the complex conjugate and their product. So you find the complex conjugate and then multiply the 2 together to find their product. So you're finding the complex conjugate and then multiplying those 2 together. The back, you're going to just have the 1.